Can you run traditional Lionel locomotives on DC power? We'll show you how, why, and when on this episode of Toy Train Tips and Tricks. Hello again, this is Mike with Toy Train Tips and Tricks. It is considered a truism among Lionel collectors and operators that, with the exception of a few specially made, low-budget starter sets in the 1970s through the early 1990s, traditional Lionel trains cannot operate with DC power. Some say it's because the three-rail track demands the use of AC power, and others say it's the traditional Lionel pull-more open-frame motors that require AC power to operate. But in this case, the truism is simply not true. While there are certainly compatibility issues involved, three-rail trains can in fact operate with DC power, and in fact Lionel, K-Line, Williams, and even Marx made some DC-powered three-rail trains. And the traditional pull-more motor is not technically an AC motor, but in fact is a universal motor capable of operation with either AC or DC power. So let's take a look at the advantages and disadvantages of running your trains on DC power and ways to incorporate DC operation into your regular AC-powered railroad. First, let's talk about motors. And please forgive my terminology. I am not an electrician, and I do not pretend to be one here on YouTube. So I may get some of these terms incorrect, but I strive to get the general ideas right. The typical permanent magnet or CAN motors used by most models today are designed strictly for DC power. Changing the polarity of the DC current changes the magnetic orientation of the motor and causes the motor to spin in one direction or the other. Since AC power essentially changes polarity many times per second, feeding AC power directly into a CAN motor will result only in a loud vibration and no movement at best, or a burned out motor at worst. In order for these motors to work with typical Lionel AC power, circuitry aboard the locomotive must first rectify the current, changing it from AC to DC for use by the motor. So why not just use DC power in the first place and forget about the rectifier? Well, hold on to that thought for a few moments. For an open-frame universal motor like Lionel's pull-more type, direction change is accomplished by changing the electrical orientation between the brushes and the motor field, which is essentially an electromagnet or a temporary magnet, as opposed to a permanent magnet in the CAN motor. These changes are made by alternating the contacts on an electromechanical reverse unit, or E-unit. Without this device, the motor has only one orientation and will only spin in one direction. As with some of Lionel's late 1960s starter set locomotives, since polarity makes no difference at all, the motor doesn't care whether alternating current, AC, or direct current, DC, is used. In fact, changing the polarity of the DC current makes no difference whatsoever in the rotation of the universal motor. It can only be reversed by changing the orientation of the brushes in the field. So why mess with AC current at all? After all, DC motors are less expensive, smoother running, and using DC current would eliminate the need for a rectifier and a reverse unit. So why do we do it? The three biggest reasons are whistles, horns, and bells. When Lionel first invented the magic of onboard locomotive whistles in the 1930s, it was because of the discovery that adding DC voltage to an existing AC voltage could operate a special relay while having little or no effect on the locomotive motor. This relay ignores the alternating current and only opens in the presence of the DC current. This relay could then turn on a motor to operate an air whistle, or later could open a switch allowing a diesel horn to sound. Later, they discovered that by using two specific polarities of DC current, Lionel could activate two different outcomes, both a bell and a whistle, or a bell and a horn. This technology, although with different component circuitry, is essentially the same whether one is sounding the whistle of a 1938 torpedo steamer or the horn of a 2008 GP38-2. With DC current, these relays would be always on, and the horns and whistles would be constantly sounding. or they need to be disconnected altogether. So, rather than abandoning a popular selling feature of their trains, Lionel and others chose to keep AC power as the standard for their trains. So, what are the disadvantages of DC-powered Lionel trains? We've already mentioned the first. Bells, whistles, and horns must be deactivated or they will sound continuously. But locomotives without these features? No problem. The second disadvantage is magnetization. With prolonged exposure to DC current, solenoids, such as those in the locomotive reverse units or track-powered turnout motors, can become magnetized and tend to stick in one position. But this magnetization can be reversed with exposure to AC current. Also, while it is theoretically possible to operate locomotives with modern electronic reverse boards and sound effects on DC current, I strongly recommend against that. Again, I strongly recommend against that. These boards are designed to survive short bursts of DC current with the sounding of a horn or a whistle, but they are likely not designed to experience prolonged, continuous DC current. Without knowing the specific tolerances of various components, one cannot verify that this practice would be safe for your electronics. It's better to be safe than sorry. Also, universal motors tend to operate a bit hotter when using DC current. Keep this in mind when running for prolonged periods on DC power. So what are the advantages of using DC current? First, having a DC option allows you to mix in less expensive DC-only Lionel trains with your fleet. Some DC models, such as the Pacific Steamer in the New Englander set, or the James Gang DC-only General Steamer, are cheaper than their AC-powered versions, while having the same level of detail as their AC versions. Second, E-units do not vibrate when running on DC power, making the locomotives quieter in operation. And you can still use the traditional E-units for reversing and neutral with no modifications whatsoever. Third, traditional motors tend to operate smoother and at lower speeds with DC power. Fourth, some modern diesels with burned-out circuit boards can easily be converted to DC-only operation by removing the reverse and sound boards and wiring the motors directly. Direction can be changed from the transformer by changing polarity. Now, you do lose some of the features, but you'll get a smooth-running, well-detailed locomotive at a junk price. Fifth, some older models without reverse units can be modified to reverse with transformer polarity, and this will be the topic of an upcoming episode. So, how is it done? If you just want to incorporate cheaper DC-only models into your operation, you can simply use a Lionel DC power pack, or pick up a cheap HO scale pack. Wire this into your existing layout, but use a toggle switch so you can switch back and forth to a regular AC transformer whenever you like. If you want to run traditional pull-more motored models on DC power, however, these small HO packs will not provide sufficient power to get the job done. To do this, you will need to use a regular Lionel transformer and rectify the power to DC. Lionel made several converters over the years to do just this, or you can build your own, which I'm going to show you in just a moment. To do this, you will need a double pole, double throw switch. It could be a toggle, a slide switch, whatever, but double pole, double throw is the most important. You will also need a full wave bridge rectifier and a project box to put everything in, or you can mount the components to your control panel. I designed my own box and printed it on my Creality Enter 3. This file is now available for free on Thingiverse, and you can find a link in the video description. By the way, regular viewers might notice that I've added this cool enclosure to my print area. It keeps the dust and debris of the workshop away from the printer, it reduces noise, and helps maintain constant printing temperature even in a cold Midwestern basement in the wintertime. And it's fire retardant in case of a critical malfunction. There are several available on the market, but I found this one to be not only inexpensive, but also very easy to assemble. You can find a link to this and the other components mentioned in this video in the description section. Electrically, to do this project, it's very simple. You need two components, the most important of which is a full wave bridge rectifier. There are several different designs of these. I like the square ones here, and this one is really overkill. This one, I believe, is rated for about 125 volts. I actually got this years ago at a actual physical brick and mortar Radio Shack store, so it's been in my parts drawer for a while. Normally, when we think of electrical components, we think of having two similar contacts next to each other. But in the case of this bridge rectifier, it's actually diagonal. If you see this plus sign here, this is going to be the DC positive coming out of the rectifier. The DC negative is going to be the opposite diagonal. These other two, pick one, are your AC inputs from your transformer. One is marked, the other one is not. But again, these are diagonal as well. So the wires coming from your AC transformer will go here and here. The current will be converted from AC to DC and will output with the positive here and the negative here. Then we'll take a wire from the positive and a wire from the negative and take that to our next component, which is some sort of double pole, double throw, toggle, slide switch, any type. Double pole, double throw. Center off is okay, but just on is sufficient. This will be used to change the polarity going out to the track to control the direction of our DC-only locomotives. So take the positive from your bridge rectifier, place it on one terminal, the negative on another, then crisscross, run the connection from here, diagonal to here, and from here, diagonal to here. That way, as you change the switch back and forth, you're changing from polarity this way to polarity this way. The two center contacts will then go to the track. And that's all there is to it. Okay, so it's time for a smoke test here and a demonstration of what the difference is between the DC and the AC power. Now, by accident, I discovered you don't want to try to wire this up using a modern transformer like the CW80 here. The reason is that a lot of modern transformers like the CW80 use a pulsed power method. While this does work, the pulsed power makes for very rough operation on the DC side. So I've temporarily wired in this Marx 1825 transformer, a standard type transformer, into my rectifier box. And we've got an MPCU 36. This has no sound. It has a traditional Pullmore motor with a traditional electromechanical E-unit. Here we are on just regular AC power. And hear that E-unit in neutral. There's the hum. And let's check low speed operation here. Let's see how slow we can get it. It'll run slowly, but listen to that growl. So what you're going to notice right away is that on the DC power, you do not hear the buzz of the E-unit. Very, very, very little electronic buzz here versus with the AC, it would be quite a loud buzz. And you can cycle through the E-unit just like you normally would. There's reverse, neutral, forward. And you also notice I can really creep this thing down speed-wise, and you don't get that growl that you normally hear with the Pullmore motor. Come back into the frame. There we go. How about a standard Mark 66 with its two-position traditional E-unit? Smooth as glass. And how about DC only engines like this Williams Mighty Might? And change direction. So there it is, an easy and inexpensive way to incorporate DC power into your existing AC layout. As always, I hope you liked the video as much as I enjoyed making it. And if so, please like it, subscribe, share, tell your friends, and tell your neighbors. So until next time, keep those trains running on AC or DC power, and we'll catch you next time on Toy Train Tips and Tricks.